Hello everyone, this is Ian. This video will be about the version 1.4 of Random Flow and what to expect with it. The new functionalities as well as the updates on the existing ones. So first off, we're going to Random Loop Extrude. So there's a new solver. So the old one, which is none, edge and face, has been replaced by sampling and recursive. Sampling is kind of like the old face solver, but much better. And recursive is um, the new one, which is um, a bit slower, but reacts much better with triangles and also tight areas, and also has much better reaction when it comes to panel sizing and the loop ratio. So I've also exposed the path, which is going to, for example, if you choose shortest, it will favor the faces that have the shortest edges and will walk on those faces instead, or generate islands from those faces instead. So size mode, you can choose between percentage or using number. And we have randomized island height. Now you can randomize uh, the height per face islands, not just the whole loop objects. And we have split islands. You can choose to split those islands as individual islands by separating them between their borders. So you can use random v color to uh, to give individual colors on each islands. We have random panels changed on the solver as well, and the rest has been untouched. So dissolve edges is also now limited dissolve, and that's also true for random loop extrude. So by the way, the new version will have changes on the UI and also the solvers, but um, if you're watching the old videos, you can see me work. I'm not really relying too much on the specific role of every properties. So I'm generalizing on the functionality because this is random. So whatever you see in the old videos, you can still do using the new ones. The important thing is you follow the workflow. And random axis extrude, random scatter. So random scatter will now auto bisect geometry that have surpassed the symmetry line of the mirror modifier. So for example, this one here. So instead of overlapping on the other side, they're now joined as one. Random tubes will now, so uh, I've just recently noticed that the length is not reacting correctly. So if from before, if I, for example, use length of 1, so it will be two lengths instead of one, two edges. So that's one edge. So from before, two edge, so there's no one edge from before. Two edge, if you select 3, there's no 3. So it only changes on the positive number. So right now it's fixed. So 5, 4, 5, 6, 7, 8. Hopefully in the next version I'll introduce some sort of fitting at the start and at the end, and also maybe at the body. If I can figure out how to do it. And we have the new operator, apply mesh, and also the merge objects, which is for the 3D print crowd, but this is highly experimental and prone to freezes, especially on complicated setups. So try this instead on simpler designs. So for the random loop extrude, let's try this one. Since there are new properties for both random loop extrude, the property solver has been changed as well as random panels. Your old presets, if you select them, will give you an error because one of the property has been changed in the saved preset in the user app data. I think the address is in the documentation or where you can find the preset folders. So all you have to do is remove them. If you, for example, select the preset and it shows you the error, just ignore the error, the warning sign or the warning message, and then use the minus symbol to remove them. Or you can go to the address and uh, just delete the folder manually, and then create a new one for the new properties. So as we can see here, so now the loop panel size reacts correctly. So 80, I mean this determines the size of the island, and the loop ratio determines the size, the number of faces is going to be randomized. So for example, these selected faces here, depending on the subdivision, loop subdivision, and base cuts. So the resulting subdivision is what we're going to use in this percentage here. So 50% of those subdivided faces we're going to use. So this is it. And loop panel size. So for example, 0 panel size. So that's it. And if we use 100%, all of those, there we go. So that's our subdivided faces. So if we increase the panel size, 20%, 100%, it covered the entire face selection. So 50%. Now the loop panel size reacts much better, especially in the recursive solver. 20%, 50%. The smaller you get, the more islands you have. And this is relative to the loop ratio. So 50% of those subdivided faces, 5% of those subdivided faces, 1%, 0%, 50. So you can see the connection between the two. So you can choose to so for example, I'm getting this one. I'm going to use 50% of this result. Let's use symmetry, XYZ. So 50% of the subdivided faces. Let's knock this down to 2. With loop panel size of 10% on loop 1 object. So this is what it looks like. And then you can use the random seed. So you can increase the amount of faces that you're going to use. Same here. If you're not using original only, loop object number 2, 3, 4, 5 will be sourced from the previous loop object. So for example, loop number 2 is being sourced from the loop 1 object. Loop 1 object is being sourced from the source object or the faces that you've selected. But if you tackle this, then all loop objects will only be sourced from the source mesh. You can see here loop number 2, they're overlapping because they're being sourced from the source mesh, and they have the same bottom or height below. So you have to differentiate to increase the height of another loop object to really make the other layers pop. Give this a difference of division. So let's say 80, and then 2. So you can create some basic layering technique using the original only. So if you toggle up original only, then loop 2 is sourced from loop 1 and loop 3 is sourced from loop number 2. So you can see here, if I toggle up 2 and 1, you can see that loop object number 3 is floating. Whereas if I use original only, it will only be sourced from the source mesh. This is faster. Using original only is faster because if you're sourcing from the previous loop object, of course, if this has 3 subdivision, loop 2 object will inherit that, and then using this resulting faces, which is subdivided by 4, it will subdivide it by 2. So this method is slower, especially with subdivided faces. So this is the fastest solver, but less detail. Just a bunch of blocks. With subdivided faces, if you have this off and you're tempted to go higher because this is faster, before switching to subdivided faces, look at your subdivision. If it's too high, it's going to freeze. So before switching this on, just lower it. Lower the subdivision first before switching this on. Okay. I might have to figure out some uh, warning for this. Okay, so that's the recursive, and it's much better in dealing with triangles, and you can see it clearly with random panels. So it's sampling. If I increase the panel size, it barely affected this side here where the triangle is. Let's knock off or lower the subdivision. But if I use recursive versus sampling, in most cases, sampling will be the fastest solver than recursive. And it's also true for random loop extrude. Sampling, but not all the time, because sampling will create more faces or more islands, and that means more noise and also more stuff to process. So it's kind of like an interchange. There's a balance of speed between the two, and I'll just let you figure that out. So basically, the more faces you have, or the operator to process, then the more subdivision, then the slower the operation becomes. So you have to balance your intended details with it. Snap off the wireframe. And let's try the rest of the operator. The new operators, which is apply mesh and merge objects. So auto mirror. Okay, let's just create a basic design. Random panels. Let's remove the center line and try to remove the automatic cut in this uh, angled edge here. So this is the cut. This is the purpose of the cutoff. So 45 degrees. So it no longer cuts automatically cuts. So the cutoff is separate from the uh, island cuts. So if, for example, 45 degrees, it no longer cuts on these edges, but it cuts here because the island, the script has walked on this edge here. So we have to remove it using the random seed. But uh, let's try the other. Let's try modifying the other. Wait a minute. X, Y, and Z. There we go. Let's try and avoid the let's try this one and introduce a second layer. Link flat faces. Set this to 0 and just use inner. Thickness and depth. Let's have a closer look. Let's try 10%. I'm just looking for a pattern that I like. Yeah, we could go with this. So using inner basically just gives you this thin wire that you can bake to a normal map, and also you can also bake this to a normal map. But this is just to layer something on top of the other result and not create too much geometry. So we just need even at this distance, the viewer can tell that it's actually a separate geometry. Let's create some sort of inner mechanism here using random loop extrude. 70%. Let's try 80% and 60% for loop number 2. And then we still have the source mesh exposed at some part. We can layer random panels on that. Use clear faces none and increase the thickness so we can see the line much better. Okay, and the rest of this, going to quantify this using quad slice, random panels, recursive, and let's just try and put those thin lines here on this part here, inner, you can actually create another one and use different subdivision and layer it on top of the other effects. Okay, so we have this, and we can try and clean this up. Use limited dissolve. This will get rid of the quad structure, but will give us a lighter model. So GT, clean up. I'm not going to use remove doubles because this will remove the island structure and meld the islands together. So that's for later. After I have colored it using the vertex color. Limited dissolve, degenerate dissolve. This removes 0 area faces and 0 length edges. Okay. So from 30K, we have 10K tries. Now let's look for stuff that has been destroyed. So we can undo it before we proceed. Everything seems okay? Okay. Now we can try joining this into one object. Because you can see here, that's a lot of objects. You can try and put this into collection. And then cursor selected. Parent the entire thing to an empty. The entire collection to an empty. And then move it around like that. But that's of course too complicated. So uh, that's a bit just a bit too complicated. So we can join them instead using the apply mesh. If we just this is designed to apply the symmetry or the mirror. If we just use this as it is, it will apply the entire mesh. or in the selected objects, apply all the modifiers to it, on it, or on each object. That's why it's called apply mesh. Or if you just select apply mirror modifier only, it will only apply the mirror modifier on those objects and leave the other modifiers alone. So for the more complete explanation about this, you can read the documentation. And we can choose to, so I'm going to just apply everything. And since it's just using mirror modifier, so you can choose to join the objects. And in the selection, you can select the master object that's going to be joined to. So I'm going to use the cube, which is the source mesh, and mesh the vertex group. So each object will be assigned as a vertex group um, in the new unified object. So okay, we can still color this using random V color by using the island limit. Okay, so everything's here. Everything is still here. So since every one of the objects is symmetrical, you can choose to reapply the mirror afterwards. X, X, Y, and Z. So this is our real geo, and this is our mirror modified geo. And now you can do stuff like bisect. If you want to go bisect, just turn off clipping and merge, and then you can do stuff like this. Turn it into another design. So you can save this object much easily as an asset in the asset browser rather than, because the asset browser can only save, I think, objects, not collections, I think. So it makes it easier to use with the asset browser. And then you can just assign the bisect. I use the bisect method to turn it into different objects every time you want to use it. So for example, this crate becomes something like this, becomes like that, uh, longer, taller crate, becomes like this. Okay, so the join process is not, it didn't really meld the objects together. It's kind of like this. Control J. It just joined the objects. So as you can see here, the vertices, the faces are not melded together. Basically, the entire mesh is just joined together. So when we use the apply mesh and then join the objects and use this, we basically stored it in the vertex group. So we can call them back, select, Shift H. This is our source mesh. So for example, this one here, select. So each one of the objects from before are still here in uh, the names for the vertex group. Their object names from before has been used as the name for the vertex group. So our panel 2, you can see here, our panel 2, oops, select. So everything's still here. So you can choose to separate them or isolate them by pressing Shift H in edit mode to work on them separately, or select them or delete them, remove them, or separate them using P and then using selection. So everything is still here. So nothing is joined. Nothing, they are not Boolean together. Nothing is actually um, melded. You can see here, if I hide the face of this object here, you can see the face of the another object underneath. So they're just layered together. So this just makes it easier to manage the object and use it as an asset on another scene. So it's actually very light for all these details, and it's still 10K drives. It's actually pretty light still, and we can actually go to 500, no problem. If you want that many crates, 200 or just 100, and you can see still okay. But for merge objects, I'm gonna hurry this up because my headphone is has crapped out and it won't charge properly, and it's giving me the warning sign that it's about to go. So this only works for really simple designs, but at least you can 3D print it. So the more islands, the more objects, the more complicated the um, design is, the slower the process will be, and it can end up the merging process can end up in a freeze. So be careful with this. So I'm just going to use a single island, a single loop object. Probably use 5%. So this is just an example, and hopefully it works. So if you're using merge, don't use inner or outer. Merging requires solid objects. In the process of merging, this faces is going to be closed underneath, and it's not possible with inner and outer. So let's say like that, and oops. So in the process of merging, the modifiers will be applied. Everything will be applied. Merge objects. I hope it doesn't crash. So this is also in the documentation. If you want to complete explanation and all the do's and don'ts, please read the documentation. So we're going to select the source object as the object that's going to be joined to by the randomized mesh. So that's cube 001. So mesh offsets basically fattens up the cube 1 object. So it basically does this, shift S, to make it better, to make it overlap with the rest of the um, objects that's going to be Boolean 2 much better. So let's go. Let's try this. Hope doesn't crash. Okay. As you can see, this is a solid object. Uh, I think. Let's clean it up. Remove doubles, submit to dissolve, and see if nothing. Okay. I guess that's it. Now you can 3D print this. This is a solid object. You can see here, if I hide this, the source object is gone from below. And this is a complete and closed mesh with some errors here and there. You have to fix this manually, but then again, at least it got you to this point instead of just manually joining each of the parts together. Okay? So with this simple model, it works. It still has problems with curved objects or cylindrical objects, but this is a start. I'll keep working on this as the Boolean modifier also gets better in the future. Okay, so that is it for this video. Read more about the new functionalities and the new updates in the documentation.